Yeah, welcome back to Practicals under course Computer Aided Engineering. And today we'll see experiment number 5. The title is Thermal Analysis, Static or Transient. And this is a problem statement for a rectangle section, width, breadth and height and the length. We have to assign the thermal properties and the temperatures and find out the temperature distribution. So let us jump back to the ANSYS workbench screen. So now here we have to select steady state thermal because this problem belongs to thermal domain. Select it, drag and drop on the main screen, and let us check the engineering data. Okay, so right click, edit. So window will appear for structural steel, and check the thermal conductivity value, which is 60.5, and our problem also demands the same value, which is 60.5. That means the material we selected is correct. So go back again, go back to project. Under geometry, right click and select design modeler to create the geometry of the for this problem. So it will take few seconds. Wait. Yeah. So before that, you have to check the units used in the problem. See, the length units are in meters, so no need to change the units. But uh, before modeling, see this white, black and white strip. It is showing this much distance equal to 30 meters, and we don't want it to be 30. So we have to zoom it. Okay, zoom it until it shows 1 meter or zero point 0.5 meter at least. Okay, now select this xy plane, right click and say look at. Okay, and now the plane is oriented towards her. Again you have to zoom it because the geometry is very small, uh, as it is shown by this white, black and white strip. Now go in the sketching tab. Under sketching tab, select rectangle because the cross section is rectangle, and using two corners create a rectangle, right? And under dimensions tab, already it is showing general, so keep as it is. Select the horizontal line and select the vertical line, and select the horizontal axis and horizontal line, and select the vertical axis and vertical line to create the symmetrical rectangle about xy axis. Now will give the inputs for height and this breadth. So height is 0.5 meter and breadth is 1 meter. So breadth is 1 meter. So I'm giving this as a 1 meter, and this distance as 0.5 meter because I want it to be symmetrical, and the height is 0.5 meters, so I'm inputting 0.5 meter as a height and this as a 0.25. Now the section is created. So go back to the modeling section. Modeling, under modeling we have to create extrude. So create, select extrude option. Now under extrude, select this XY plane, and under XY plane sketch 1, say apply. Okay, so now the sketch 1 is selected, and give depth. Okay, now depth is actually length here, which is 5 meter. So give input as a 5 and select extrude, right click and again say generate. Now this section is generated. You can just reorient it. Okay, now this is how the geometry is. Again close the design modeler, file, close design modeler. Now in model, again select model and say right click the model option, and it will open the ANSYS mechanical window. Yeah, it will take few minutes, few seconds. Yes, now it is opening. So until the geometry is fully opened, okay, the process is not complete. Yeah, now it is open. Just I'm reorienting my screen. Yeah. Now select this mesh option, right click it and say generate mesh. And we'll see how the auto mesh is. Now looking at the auto mesh, it looks like it is a very ideal elements. So no need to modify this mesh. And this select the steady state thermal, right click, say insert temperature. And on this face, okay, this is a left face and this one is a right face. So on the left face, see the temperature value, say it is 100 degrees centigrade. So click on the left face, say apply and change value to 100 degree centigrade. And again insert one more temperature and select the opposite face, which is a right face, say apply and give value as a 300 degree centigrade. And in this solution tab, insert thermal and select the temperature option because we want to see the temperature distribution. And for this select the solution, right click and say solve. Now the software will try to solve this thermal problem and it will give us the temperatures as a output. So to see the output, select the temperature, okay, and that's how the temperature distribution is shown. See the values are maximum value is 300, minimum is 100, and for all other elements it is in between 300 and 100. You can animate these results like by clicking on this play option and take the image of this and note down the maximum minimum values. That's how the thermal analysis experiment is to be performed. Thank you.